Hi, this is Kurt from Super Sky, and this is Texas Medical Center project. And we got a picture on the screen of the photo of the atrium with the steel beams. And there isn't much reference for where to start the skylight. We've just got 11 giant beams in the opening and very little else. And it's going to be important to determine where to start before you do anything. Our rafters are supposed to line up with the centers of these cutouts in the beams, and the posts also have to be on 11-foot centers across the steel beams. So the steel beams may vary. They're pretty big. They might shift an inch easy. So we've got to get our spacing correct. If you watch the mouse here, this way, and then this way, left to right, so your posts will go. And we also have to adjust for height, because it's hard to see, but each of these beams is curved upward, and they're going to come down as the glass is loaded. So we have to set the elevation of our frame to also be high, so that it'll come down to the proper finished position when all the weight is put on. One thing that's real important is, I know they built a platform under here. Make sure the platform isn't hanging on these beams. Excuse me. If they hung it on the beams, it's going to be extra weight that nobody's accounted for yet. And everything we've done is junk. We'll have to go back and refigure where to set the post. I'm sure it would still work, but all the numbers I'm about to give you will not work if the scaffold is hanging from the steel beam. It should be sitting on the floor, but we didn't really talk about it, and I don't know what Vaughn was going to do. So that's first things first, is make sure that the beams are free to bend right now, and then we'll go from there. So assuming that, we'll kind of get started, and I guess the only other thing, this is our barcode sheet. I find it a little hard to read because it's a half plan. At the top of the screen here is the ridge, and at the bottom is the curb, and you'd have to flip it over to get the other half of the skylight. That freaks me out every time I look at it. But let's move on and go to the first place. This is page 6, which is not running the view right. So you're going to have to find out which wall is I and which one is F. I believe this is the front of the building to the right, and then so I would be on that side. We could look for north arrows on the other plan. So we do not have a rafter at the center. The center line would go right through here, and the first post on each way is 5'6", 5'6". That's to locate these guys. Then you're going to go 11, 11, 11, 11, and there will be some space from the last post to the sheathing. So that space is 11 1/4 from the center of the post to the sheathing. So I think you should check the opening of the sheathing, make sure what that is. Find where the center of the skylight is, and then work back and make sure these 5'6" align with the holes correctly. You may have to shift the center line a little bit offset, so that if we use it for locating things, it's not setting you up to not align with the holes. Going back to the picture, alignment with the holes is the most important thing, I'm guessing. If we're a little bit off to the sheathing, we can adjust the flashing or something, but that's the first thing to check into. So we've got that, and then you're going to end up, let's make them a different color. I don't know if you're going to do this with snap and chalk lines, but that's 5'6", and then 11, because you're going to want to mark across each of these beams. This beam in the middle is the ridge line, and again, all you can really do is count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 to find the middle. There's nothing else that would give it away. And so if you would mark that one for center, you're then going to want to check that each of the beams going over is 11 feet 0 inches on center, because they're going to vary, and if it varies a bit, you're going to have to snap a line to hold the 11 foot, and then kind of do that throughout all of these. So eventually you're going to end up with an 11 by 11 grid, and where those lines all cross is where the posts go. So 11 foot, 11 foot, depending how much they change. I can't even draw the line straight, but that's going to be what controls. You can't just take center of the beam and assume it's going to be the right position. You're going to need the center line of the atrium, center line of the atrium, and just like it was important to check from the center line to the sheathing and the hole, you're going to want to check center line to the curb. You don't want to set up on the ridge if the ridge is the wrong bar. So let's make sure the ridge is centered between the curbs and kind of find the best fit for all of our center lines that way. That's probably step one. That gives you your 110 intersections where all these happen. And then it becomes a question of which post is going to go where. And if you look down here, this is page A6. I call the ones at the curb A. Next one up is B. There's C, D, E, the ridge is F. And we go E, D, C, B, A. Now, I've been through all this with some survey work that Vaughn did to check the steel, and I made these clouded posts a different length to suit the tolerance that we saw in the elevation. So you're going to have a CX is going to work with a C, and when you get into the layouts, I'm going to tell you exactly where those are. And I've keyed the layouts here, and that layout 1 is the ridge line. Layout 2 is going to the right, 3 to the left. 4, second down on the right, 5, second down on the left. So basically number 1 in the middle, and then evens to the right, odds to the left. And I gave you one layout for each beam to work with, because the elevations are different everywhere. So grids, and I'm kind of got to keep repeating myself so I don't get lost, but grids, find the posts. You have different posts to pick. I checked them. The steel guy made them to the right height, I believe. I didn't unwrap them, but they were all very close. The right quantities are there. You have 1 extra F and 4 extra E's in case something goes wrong and we need a different length post. Those extras can be cut to make something that we need. The F has a pitch going both ways, so I guess that was just in case one of them was wrong or got damaged. We had one more to work with. But the E is long enough that you could cut any of the others out of it. So, okay. Let's look at the... We'll go this way. So this is section A4 in the CAD file. Here's the center line of the atrium. Again, it's a half drawing. This is the far right wall, and this is the bottom of the page we looked at before. So even our infills should be centered on these holes, but here's the post, the rafter, and these little boxes are a sunshade they're going to put on after us. So we want to make sure that our rafters are centered on these holes as much as they possibly can be, while still being mostly centered between the walls. So that's the cutout. These are right off the steel drawings, so it should be pretty close. We've checked the numbers. Something could still go wrong, but I did check it as much as I could and adjust where we had to. So that's that height. Let's look at 3. If you look at 3, this gives you the height of the posts in the skylight after everything's done. So you're never going to be working with 37.59 because you're going to have a different number because we're going to shoot high, and it's hopefully all going to settle to create that number. It may be close, but there's so much stuff kind of wiggling around. But those are the nominal numbers for the posts and the place where the posts are centered. And then we will get to the elevations now. So I've given you all these sheets here with posts and all kinds of numbers. Let's start right here on the top of the beam where I wrote all these numbers. This is based on the Vaughn's original steel survey. Now, they're a little squeamish about us using that. I don't think it was very accurate. And what they did is they shot a point here, a point in the middle here, another one here, and another one at the end. So these are all calculated between the different points. And they're saying the building has settled, so they may not be correct. That's why they're going to give us a new benchmark. But I've written them down here just in case it turns out it didn't settle. We have a way to go back. Now, I'm going to come back to this because I think resurveying every point is probably going to be your quickest way to get this done. But for now, these are just for reference and just in case. And I'm using them to calculate parts to get us a starting place. So, everything I have here is a starting point. It's not, I can't guarantee it because I'm in the office working with bits and pieces of information to get you a place to begin. So this is the ridge layout, and I gave you the ridge detail, and I took the shoulder point on the outside edge of the bar so that you could measure down to the steel or up to a line or wire. So that should be 6 9/16 off the center line, your marked center line, the one you want to use, not the steel. And that would be where you would put your line. And then I picked the whole number height of 127'8". That's also the number I used for the benchmark to put your string here. So if you had a string and you offset it this much and you pulled it all the way across to the other side and you knew you were lined up to this center on the beam correctly, you will just have to measure down from that line to this shoulder per number, the dimension X, which is right here. So at post 1, you can see the 1, you would want to do the line dimension should be 2.61. So 2.61 from here to the shoulder of the bar, not the rubber, the bar underneath. The next bar down, number 2, 2.34. And these are very regular, and they just sort of raise the bar up till you get to the middle, and then it falls back down gently that way. That would be the goal for the line. Since I had these steel numbers, I had a rough idea what your shim stack might be close to. So I gave you an initial shim dimension that you could put in underneath the steel post. And we'll get to that in a separate thing. But I picked numbers and I just kind of wrote them down here. You only have eighths and quarters for shims, so I guess if you had a 7/16, bump it to a half. Just make it a little high. 3/8, 3/8, 9/16. I wrote down what I had on the sheet. You guys can adjust as you find it's working out. That's if you want to do a line. And the line is off our benchmark. These numbers up here, that's the height we're going to be up above. That's how much we expect the steel to bend later on when the glass is loaded. You don't have to do anything with that. That's there so I can keep track of it. I have two different numbers, one from our engineer, one from the building engineer, and they differ a little bit. And so I kind of hedged a little bit to the high side, and I think that's correct because our engineer didn't account for the added sprinklers and other sunshades. So I was a little worried when I wrote it, and some of these notes are really for me. As I try to get through this, I was getting a little confused. So don't be overwhelmed by the numbers. A lot of that is there for me. This is me working out the number I'm giving you. like this. I'm just picking a number so I can calculate the X. So our benchmark's 127.8. We're going to put our line at 127.8. So this dimension here is 0. That'll be different on other ones. The nominal shoulder elevation doesn't affect you. It's a number for me. When you have the benchmark at 127.8, if you want to check if the steel has settled, you can check it at 0.1 and see if it's 45 and 15/16. And I gave you a spot where you could write down what you measured. And then the same thing at 10, it should measure 46 and an eighth. And you could write what you measured. If they measured evenly, we could kind of take that adjustment and just add it here. And if we got in a pinch, we could use those as checks. I think the line is a better way to go. I also think if you had an interest in doing a laser, you could set a laser up to run at this 127.8 dimension. And if you got that keyed in on the benchmarks on both walls, you could use that laser and just take these X dimensions at every point. We'd have to adjust a little bit for the difference down, but you could just use the laser and locate the shoulder that way. The other way to go is the top of the steel. If I go back to the AutoCAD for a minute, we've had them mask off the steel at every post location. So you pretty much know where every post generally is going to go because there's a big patch of masking tape sitting there. And if you wanted to get a guy with a transit, you could shoot elevations off the benchmark and just get the relative height from the benchmark down to the steel at all 110 points. And I'll be able to go back to our layouts. I lost them. And I could recalculate based on the current top of steel at each point to the shoulder you should have, and I can give you one number, and I think that would be the easiest. It might cost a little bit. You might even be able to get Vaughn to do it. But if they shot elevations at the beam and you wrote them all down and gave them to me, next day I'll be back to you with heights for every shoulder, and you'll just have to get the posts on the center and measure from top of steel to shoulder, and you'll be good. Burn it down. That's where we're going to want to be. I think that's easier than the strings. I think it's easier than the laser, but we need somebody to shoot those heights. And Vaughn seems to have some guys on staff who can shoot elevations. Money well spent, in my opinion. It'd make your life so much easier. All you're doing is snapping chalk and then measuring up at the shoulder. Slide in the shims you need to hold the post, and you should be good. They will have the welder come and burn these down. So that's what I was talking about in my notes for the 3 different ways to do it. One is locate all these strings at just the right height, just the right location, measure down. Laser kind of does the same thing, and the steel seems simpler. And like I said, you have a layout for every post. Here's the L2. Now on here, the crossbars come down the slope, so our string line's 127.3, but our benchmark is 127.8. So you'll have to lower 5 inches from the benchmark down to your line. And you're going to see that's going to kind of consistently keep happening. You're going to have all post E on this one. This one uses all post F. This one also has all E. So here's the one, L4, second one down on the right side because it's even. You got 127.8 as your benchmark. Your line's going to be 126.9. So the difference down is 11 to get that. And then here's where your steel heights, and then your checks for the steel as well. The steel you shouldn't use to set this up on, by the way. And your post is D unless noted otherwise. And these 2 posts are the DX. And if you go back to that plan 6, they should correspond with where I clouded them. So anywhere there's a special post, I've gone in and I've marked it just CX on the where it goes. And I've numbered them all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can tell by the grid lines where that starts and how that plays across. B1BX over there. Here's 4 BXs in a row. You'll see a lot of repetition with this X dimension because I was pretty consistent how I picked the numbers. And then you always got to reference back to the benchmark to get your line. And this is your offset from the marked center of the beam. It's usually 1 9/16 or 6 9/16 at the ridge. I don't know. I think that's as much as I can put in the video about it. Everything else that's kind of marked on here is just to kind of keep all the information together so that if we start getting into some trouble, we have a way to go back and figure out, did I make a mistake or did something else go wrong? I did a lot of these all in one night, so if you start seeing like a weird number where they should be sort of gradual and follow kind of a logical way, because the beam, it rises, then it goes flat, and then it rises back down. So it's going to have a little bit of undulating to it and some tolerance, but it shouldn't make big changes abruptly. It should be all little. I got a little confused with that, but I'm pretty certain we want to do it this way, even though there's a little bit of differences. That's the tolerance is playing out. But keep an eye out, and if you start seeing the frame look really weird, let's talk about it. Don't just assume I've got it figured out. Camber's a weird thing, and it kind of freaks me out. So, feel free to call. I'm hoping this is helping you get a good start. Thanks.